Scientific data has confirmed that 3I/Atlas is a natural interstellar comet making a one-time, harmless passage through our solar system, despite a surge of online speculation and fear-driven narratives suggesting otherwise. The object, formerly designated 3I/Atlas, represents only the third confirmed interstellar visitor ever observed passing through humanity's celestial neighborhood, following the discoveries of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Its arrival has reignited scientific curiosity while simultaneously exposing the growing gap between peer-reviewed astronomy and viral misinformation. The confusion surrounding 3I/Atlas has been fueled largely by misinterpretations of its unusual trajectory and chemistry, combined with sensationalized headlines suggesting the object may be artificial, hostile, or on a hidden return course toward Earth. However, international astronomical data paint a far clearer and far less alarming picture. Independent observations from multiple space agencies and research institutions converge on the same conclusion. 3I/Atlas is a naturally occurring comet originating from another star system, passing safely through the Sun's gravitational domain before continuing back into interstellar space. The defining characteristic that confirms its interstellar origin is its hyperbolic orbit. Unlike planets, asteroids, or comets native to our solar system, which follow elliptical paths bound by the Sun's gravity, 3I/Atlas travels on a trajectory that cannot be captured by the Sun. Its velocity and angle of approach indicate that it entered our system from deep space, briefly interacted gravitationally with the Sun, and is now on an outbound path that will carry it away permanently. This orbital signature alone eliminates any credible claim that the object is coming back or looping toward Earth. The discovery of 3I/Atlas was made on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System ATLAS, a global early warning network designed to detect near-Earth objects. Almost immediately after its detection, observatories worldwide began tracking the object, refining its orbit and physical characteristics. Within days, astronomers recognized that its velocity exceeded the solar escape speed, confirming that it was not gravitationally bound to the Sun and must have originated beyond the solar system. NASA and international partners rapidly coordinated a comprehensive observational campaign. Space-based instruments including the Hubble Space Telescope, the James Webb Space Telescope JWST, SOHO, Stereo, and the newly operational Punch mission captured images and spectra of the object as it passed through the inner solar system. Ground-based observatories equipped with large aperture telescopes contributed additional high-resolution photometric and polarimetric data, allowing scientists to study both its composition and behavior in unprecedented detail. These observations revealed that 3I/Atlas displays a clearly defined coma and tail, features characteristic of comets composed of volatile ices. As the object approached the Sun, solar heating caused gases and dust to sublimate from its surface, forming a diffuse envelope and a trailing tail shaped by solar radiation and the solar wind. This behavior closely mirrors that of known cometary bodies and stands in contrast to earlier interstellar visitor Oumuamua, which showed ambiguous activity and sparked far greater scientific debate. Chemical analysis has been one of the most illuminating aspects of the study. Spectroscopic data obtained by JWST and supporting instruments indicate that the coma of 3I/Atlas is dominated by carbon dioxide CO2, with detectable quantities of water vapor, carbon monoxide, and trace organic compounds. While this composition differs somewhat from typical short-period comets found in our own solar system, it is entirely consistent with models of primitive icy bodies formed in colder, outer regions of other planetary systems. Such diversity in chemical makeup provides valuable insight into how planetary systems form and evolve across the galaxy. Polarimetric measurements have added another layer of intrigue. When sunlight scatters off dust particles in a comet's coma, it becomes partially polarized, and the degree and direction of this polarization can reveal information about particle size, structure, and surface texture. Studies of 3I/Atlas show negative polarization features that are uncommon among most solar system comets, suggesting unusual dust properties. However, astronomers stress that these features do not imply anything artificial. Instead, they likely reflect differences in grain composition or formation environment, reinforcing the idea that this object formed around another star under different physical conditions. Crucially, orbital modeling confirms that 3I/Atlas poses no threat to Earth. Its closest approach occurred on December 19, 2025, when it passed at a distance of approximately 1.8 astronomical units, or about 270 million kilometers. This distance places it safely outside Earth's orbit and far beyond any possibility of collision. Even at its nearest point, the object remained closer to Mars's orbital region than to Earth, and its trajectory continues to carry it outward at increasing speed. Despite this clarity, misinformation has flourished. Social media platforms and fringe media outlets have amplified speculative claims suggesting that 3I/Atlas could be alien technology, a probe under intelligent control, or part of a concealed threat scenario. Many of these narratives recycle themes previously attached to Oumuamua, including selective interpretations of non-gravitational acceleration and insinuations of secrecy by space agencies. One particularly persistent thread of speculation centers on comments made by Harvard astrophysicist Avi Loeb, who has publicly argued that some interstellar objects warrant consideration as potential technological artifacts. In podcast appearances and interviews, Loeb has suggested that anomalies in 3I/Atlas's motion and composition merit deeper scrutiny, and he has claimed that certain images, including a high-resolution high-rise image allegedly captured by the Mars Reconnaissance Orbiter in October 2025, were not released to the public. While such statements have attracted attention, the broader scientific community emphasizes that extraordinary claims require extraordinary evidence. To date, no peer-reviewed data support the notion that 3I/Atlas exhibits controlled maneuvering, artificial structure, or intentional behavior. Measurements of its motion show only minor non-gravitational accelerations, consistent with asymmetric outgassing, an effect well documented in many comets. These small deviations arise when jets of gas erupt unevenly from a comet surface, subtly altering its trajectory without any need for propulsion or guidance. NASA and other agencies have also rejected claims of image suppression, noting that data release schedules depend on calibration, analysis priorities, and mission constraints, not secrecy. In many cases, images taken for unrelated scientific objectives may not be optimized for public release, or may require extensive processing before they are scientifically meaningful. No credible evidence has emerged indicating that critical observations of 3I/Atlas have been intentionally withheld. The episode highlights a broader challenge facing modern science: the speed at which speculation can outpace verification. Interstellar objects are inherently rare and scientifically exciting, making them fertile ground for sensationalism. Yet they also offer an unprecedented opportunity to study material formed around other stars without leaving our solar system. Each confirmed interstellar visitor provides a natural sample of galactic matter, carrying chemical and structural information from distant regions of the Milky Way. In this context, 3I/Atlas represents a scientific milestone rather than a cosmic threat. Its safe passage through the solar system has expanded our understanding of cometary diversity, validated models of interstellar object capture and detection, and demonstrated the effectiveness of modern astronomical surveillance systems. The coordinated response by observatories worldwide underscores the maturity of planetary defense and deep space monitoring infrastructure. As 3I/Atlas continues its outward journey, fading as it recedes into the cold darkness between stars, astronomers will continue to analyze the wealth of data collected during its brief visit. Long after public attention shifts elsewhere, its legacy will persist in scientific literature, refining our understanding of how common such interstellar travelers may be and what they can tell us about the broader cosmos. Ultimately, the story of 3I/Atlas is not one of danger or deception, but of discovery. It serves as a reminder that the universe is dynamic and interconnected, with material constantly exchanged between star systems over cosmic timescales. While speculation and fear may dominate online discourse, the evidence remains clear. 3I/Atlas is a natural interstellar comet, passing safely through our solar system, offering knowledge rather than menace as it journeys onward into interstellar space.